Nobody sent you that message. So how did it reach your phone? 3:17 in the morning. You're asleep. The room is dark, the house is quiet, and then a sound. Not your alarm, not a call. Something different, something that doesn't ask for your attention. It takes it. Your heart is pounding before you're even fully awake. Your hand finds the phone, and glowing on the screen, 3 words: emergency alert. Take action now. Across the city, the same sound. Across the state, the same sound. Millions of phones, millions of people, all jolted awake by the same message at the same second. And then it happens again. Maybe not tonight, maybe not this year, but the next time it does, the next time that sound cuts through the silence. Do you know what actually made that possible? Because what just happened is one of the most complex and quietly extraordinary feats of engineering on the planet, and nobody talks about how it works. Today, we fix that. To understand why emergency alerts are so impressive, you first have to understand what came before them. For most of history, warnings spread slowly. Emergency communication ran through television and radio interruptions, broadcasters cutting into regular programming to announce a threat. Towns had sirens mounted on poles. Police drove through neighborhoods with loudspeakers. It worked, sometimes. But the system had one fatal assumption built into it. It assumed people were paying attention. If you weren't watching TV, you might not see it. If you were indoors with the windows closed, you might not hear the sirens. If you were traveling, you might miss everything entirely. And in fast-moving disasters, a tornado that shifts direction in seconds, a flash flood filling a canyon, a missile launch, those missed minutes aren't inconvenient. They're deadly. Emergency planners and engineers recognized something important. The only reliable way to reach people was through the device almost all of us carry everywhere, our phones. But here's the problem. In the US alone, there are more than 300 million active mobile phones, connected to hundreds of thousands of cell towers. If you tried to send an emergency message like a regular text to every single device, the network would buckle under the load. Traditional messaging is what engineers call point-to-point communication. One sender, one receiver, one connection per message. To reach 300 million people that way, you'd need 300 million simultaneous connections. The internet would choke, the cell network would collapse, and in a disaster, when those networks are already stressed, it would be catastrophic. So engineers went back to the drawing board. And what they came up with was genuinely clever. The secret is a technology called cell broadcast. Here's the key insight. Instead of sending messages to phones, the system sends messages to cell towers. And then, those towers broadcast the alert outward, like a radio signal. Think about how a radio station works. The station doesn't call each listener individually. It doesn't have your number, it doesn't know you exist, it simply transmits a signal into the air, and every radio tuned to that frequency receives it at the same moment. Emergency alerts work the same way. One signal per tower. Thousands of devices receive it instantly. No individual connections, no traffic jam, no collapse. One broadcast, millions of recipients, zero congestion. In the United States, this system is coordinated at the federal level through FEMA, the Federal Emergency Management Agency, and the FCC, the Federal Communications Commission, under a program called Wireless Emergency Alerts, or WEA. When an authorized official, a meteorologist, a law enforcement commander, or an emergency manager makes the call to issue an alert, the message enters the system. It's routed through federal infrastructure to mobile carrier networks. Those carriers push the signal out to the towers covering the targeted region, and within seconds, those towers light up with the same pulse. Your phone doesn't need to be registered. The system doesn't need your name or number. It only needs one thing: that your phone is on, in range, and capable of receiving the signal. And then, millions of devices vibrate together, a synchronized heartbeat across cities, highways, and neighborhoods. I want to pause for just a second. Most of the systems that protect modern civilization are completely invisible until something goes wrong. Power grids, water treatment, emergency communications. We rely on them every single day, and most of us have no idea how they actually work. Actually, that's exactly what this channel is about. If you want to understand the hidden engineering holding the world together, subscribe to Engineering Your World. The link is right there. Okay, let's keep going, because it gets even more interesting from here. One of the most impressive things about modern alert systems is something called geographic targeting. If a tornado is tearing through one county, there's no reason to wake up an entire state. Using cellular network coverage maps, the system can activate specific towers covering specific areas. If your phone is physically in that zone, you get the alert. If you're outside the danger area, you don't. And here's what makes this remarkable. The system doesn't care where your phone number was issued. It doesn't care what state you're from. It only cares where you are, right now. That's why travelers sometimes receive alerts in places they've never been before. The moment your phone connects to a local tower, you become part of that region's warning network. Now, here's the part that surprises most people. You can silence your calls, you can mute notifications, you can set your phone to Do Not Disturb, but when a severe emergency alert is issued, your phone ignores all of that. Manufacturers program devices to override silent mode, specifically for these alerts. That sharp, distinctive alarm tone isn't an accident. It's engineered to be impossible to sleep through, to be recognizable in a split second. Because the whole point is, you cannot miss this. The technology is fascinating, but there's a part of this story that doesn't get talked about enough: the human part. Every alert starts not with code, but with a decision. Somewhere in an emergency operations center, people are watching data. Meteorologists tracking a tornado that just changed direction. Law enforcement confirming an active threat. Officials staring at a radar screen at 3 in the morning, deciding whether the situation has crossed the threshold. Issuing an alert isn't a small thing. Too many false alarms and people start ignoring them. Too slow and lives are lost. Every alert is a calculated judgment call under pressure, made by real people who carry the weight of that responsibility. And the system that delivers their decision was built through a different kind of pressure, through failure. After Hurricane Katrina in 2005, investigators found catastrophic gaps in public warning systems. People didn't receive information fast enough. The warnings that existed didn't reach enough people in time. The same lessons came from major wildfires and earthquakes. Each disaster revealed what the next version of the system needed to fix. That's how the wireless emergency alert system came to life, launched nationally in the United States in 2012. The result of emergency agencies, telecom companies, phone manufacturers, and governments all agreeing on a shared standard for the first time. The United States isn't alone in building this. Japan has one of the most advanced alert systems in the world, capable of detecting an earthquake and pushing alerts to millions of phones in the seconds before the shaking arrives. If you've ever seen those videos of Japanese phones all going off simultaneously in a restaurant or a train station, that's the system working. Canada operates Alert Ready. European nations coordinate alerts across borders through shared frameworks. And the underlying standard, Cell Broadcast, is now part of how 5G networks are being built globally. The systems are also designed to never have a single point of failure. If cell towers are damaged, satellite-based messaging can route alerts through alternative infrastructure. Highway message boards light up. Television and radio systems trigger automatically. Emergency broadcasts layer on top of each other, redundant pathways ensuring that even if one fails, others carry the warning forward. In engineering, this is called resilient system design, and it matters in disasters because disasters often destroy the infrastructure you need most. And the next generation, it's already in development. Future alerts could include embedded maps, real-time evacuation routes, and live visual updates, not just text. Satellite constellations like Starlink are being tested as emergency communication backups for when ground infrastructure fails. And AI systems are now being trained to detect the early signatures of wildfires, seismic events, and severe weather faster than traditional monitoring, which means alerts could go out earlier than ever before. In emergencies, minutes matter, seconds matter, and engineering is relentlessly chasing those seconds. So the next time that alarm sound cuts through your sleep and your heart jumps before your brain even catches up, take just 1 second before you react. That message didn't appear out of nowhere. It traveled through emergency operations centers where people were watching data through the night, through government agencies and carrier networks, through thousands of cell towers broadcasting simultaneously across cities, highways, and rural roads, through a legal framework built from lessons learned in disasters, through devices designed by engineers who spent years making sure you couldn't ignore this, even in your sleep. All of that, moving at the speed of light to deliver one message. You need to know this, right now. We tend to measure technology by convenience. Faster downloads, sharper screens, smarter apps. But emergency alert systems measure technology differently, in lives protected, in minutes gained, in warnings that arrived before disaster struck. And that's the kind of engineering that quietly holds the world together, every single day. If you found this interesting, there's a lot more where that came from. The next video on this channel goes inside another system you depend on without ever thinking about it. If you're not subscribed yet, now's a good time.